Yes. Good morning. In our last class, we were discussing the synopsis part of electric potential and capacitance, and we were discussing the potential of a large drop formed by combination of n small drops, each having charge small q and radius small r. We'll continue with that discussion in this class. Before that, I would like to recall you certain things. Yes. So here we have the concept of electric potential due to a charged spherical shell of radius r. Actually, this derivation is not mentioned in our syllabus. We are not expected to derive the expression for electric potential due to a charged spherical shell. One charged spherical shell in the electric potential ಎಷ್ಟಿರ್ತದೆ ಅನ್ನೋ derivation ನಮ್ಮ syllabus ನಾಗಿಲ್ಲ, but you need to know its equation. See, due to a charged spherical shell of radius r, here I have represented a charged spherical shell of radius r. Due to this charged spherical shell, electric potential on its surface. See, this charged spherical shell produces potential on its own surface. The electric potential on its own surface due to this charged spherical shell will be given by 1 by 4 pi epsilon naught q divided by r, where q represents charge on the sphere. See, on this sphere we have distributed some charge. That charge is q and its radius is r. So electric potential on the surface of a charged spherical shell is 1 by 4 pi epsilon naught q divided by its own radius. Notice this is the formula for electric potential due to a charged spherical shell on its own surface. A sphere the surface mal potential beku antandre 1 by 4 pi epsilon naught q divided by its own radius r. See, due to a charged spherical shell, we can find electric potential at 3 points. More point hatra electric potential find out ಮಾಡಬಹುದು. One on its own surface, electric potential on the surface of the shell. Next, we can find out electric potential at a point outside the shell. See, here we have a spherical shell of radius small r. Here is a point P, which is well outside the shell. ಈ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಹೊರಗಡೆ ಇರೋ ಒಂದು ಪಾಯಿಂಟ್ ಹತ್ರನೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಇದು ಎರಡನೇದು. ಮೂರನೇದು, ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಇನ್ಸೈಡ್ ದ ಶೆಲ್. Look here, the point P is well inside the shell. So we can do three cases with respect to a charged spherical shell. We can find electric potential at a point on the spherical shell. We can find electric potential at a point outside the spherical shell. And we can find electric potential at a point inside the spherical shell. On the spherical shell, electric potential is given by V on, potential on the spherical shell. 1 by 4 pi epsilon naught q divided by r, its own radius. Electric potential at a point outside the spherical shell. See, this is the spherical shell of radius small r. P is a point at a distance capital R from the center of the shell. From the center of the shell, point P is at a distance capital R. E point hatra, E charged shell in the potential beku antandre, E point hatra electric potential eshtirtade antandre, due to this charged spherical shell, electric potential at point P, which is well outside the shell, is given by V out is equals to 1 by 4 pi epsilon naught q divided by distance of that point from the center R, capital R. 1 by 4 pi epsilon naught q divided by capital R. Right? This is at a point outside the sphere. And when the point is inside the sphere, inside the sphere, point irli, at a point inside the sphere, electric potential is same as on its surface. Spherical shell surface mal potential eshtitte nodri. On its surface, electric potential was 1 by 4 pi epsilon naught q by r. At a point inside the sphere also, the electric potential will be 1 by 4 pi epsilon naught q by r. Andre, at a point inside the charged spherical shell, electric potential will be same as on its surface. Surface mal eshtu potential irtudo, at a point inside the spherical shell, the potential will be the same. Illi torsi nodri. Here is a charged spherical shell. Here is a charged spherical shell. Just a minute. Yes, ಇಲ್ಲಿ ಸರ್ ಬಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ವೇರೀಸ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಇದಕ್ಕೊಂದು ರೀಸನ್ ಅದೇ. At a point inside the charged spherical shell, electric potential does not depend upon the distance of the point. Yakantandre, at a point inside the charged spherical shell, electric field will be zero. Inside charged spherical shell, there will be no electric field at all. Elli electric field zero irthudo alli electric potential constant irthude. Next paper na ತೋರಿಸ್ತೀನಿ. ನಮಗೆ ಗಾಸ್ ಲಾ ಅಪ್ಲಿಕೇಶನ್ ಡಿಲೀಟ್ ಮಾಡಿರೋದ್ರಿಂದ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಒಂದು ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೋಬೇಕಾಗ್ತದೆ. ನಮಗೆ ಗಾಸ್ ಲಾನಾಗೆ ವಿ ಹ್ಯಾಡ್ ಟು ಡಿರೈವ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಇನ್ಸೈಡ್ ದ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಮಾಡಬೇಕಿತ್ತು. ಬಟ್ ಆ ಪೋರ್ಷನ್ ನಮಗೆ ಡಿಲೀಟ್ ಆಗಿರೋದ್ರಿಂದ ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್ that electric field inside a charged spherical shell will be zero. ಈ charged spherical shell ಒಳಗಡೆ ಯಾವುದೇ electric field ಇರಲ್ಲ. Electric field ಇಲ್ಲ ಅಂತಂದ್ರೆ there will be no opposition for the motion of the charge. So electric potential at a point inside the spherical shell, charged spherical shell, will be same as on its surface. ಇಲ್ಲಿ ತೋರಿಸ್ತೀನಿ ನೋಡ್ರಿ. Here is a charged spherical shell. On its surface, the potential is 10 volt. ಈ charged spherical shell surface ಮೇಲೆ potential 10 volt ade. Hagadre what will be the electric potential at any point inside the spherical shell antandre it will be 10 volt again. Point A hatranu 10 volt irthude, point B hatranu 10 volt, point C hatranu 10 volt. At any point inside the spherical shell, electric potential is same as on its surface. Surface mele ಎಷ್ಟು potential irtudo, charged spherical shell ಒಳಗಡೆಗೂ ಅಷ್ಟೇ electric potential irtude, right? So electric potential at a point inside the spherical shell, V in and V on, electric potential at a point on the spherical shell are the same. 1 by 4 pi epsilon naught Q divided by R. What does small r represent? Under small r represents radius of the sphere, but it is different when the point is outside the shell. If the point is outside the spherical shell, electric potential is given by 1 by 4 pi epsilon naught Q divided by capital R. Capital R is not the radius of the sphere. Radius of the sphere is small r. Capital R is distance of the point from the center of the shell, right? So how does electric potential due to a charged spherical shell vary with distance? How does electric potential due to a charged spherical shell vary with distance? How does it vary with distance? How does electric potential due to a charged spherical shell vary with distance? How vary ಆಗ್ತದೆ? At a point on the sphere and at a point outside the sphere. ಎರಡೇ ಆಲೋಚನೆ ಮಾಡಬಹುದು. Inside the sphere distance variation ತಗೋಬಾರದು. At a point on the sphere and at a point outside the sphere. How does it vary? At a point on the sphere and at a point outside the sphere. Electric potential is inversely proportional to the distance. ಅಷ್ಟೇ. Square of the distance, cube of the distance ಇಲ್ಲ. Is potential due to a charged spherical shell clear? ಒಂದು ಚಾರ್ಜ್ಡ್ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತದೆ ಗೊತ್ತಾಯ್ತಾ? A charged spherical shell produces a potential equal to 1 by 4 pi epsilon naught Q divided by R. ಒಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕೂಡ ಇಷ್ಟೇ ಪೊಟೆನ್ಶಿಯಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತದೆ. If you remember, electric potential produced by a point charge also produces a potential equal to 1 by 4 pi epsilon naught Q by R. So a charged spherical shell is like a point charge. A charged spherical shell is like a point charge with all its charge present at the center. Now one spherical shell, charged spherical shell na point charge anta consider ಮಾಡಬಹುದು. ಯಾಕಂತಂದ್ರೆ spherical shell ಎಷ್ಟು electric field potential produce ಮಾಡ್ತದೋ point charge ಅಷ್ಟೇ potential produce ಮಾಡ್ತದೆ. Electric potential produced by a point charge and electric potential produced by a spherical shell are the same. So we can consider a charged spherical shell to be a point charge. In case it's negative, sir. If the charge on the spherical shell is negative, electric potential becomes negative. If the charge on the shell is negative, electric potential will be minus 1 by 4 pi epsilon naught Q by R. Potential being a scalar quantity, you have to consider the sign of the charge. ಇಲ್ಲೇನಾದ್ರು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಸೈನ್ ಹಾಕ್ಬೇಕು. ಮೈನಸ್ 1 by 4 pi epsilon naught Q by R. ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ 1 by 4 pi epsilon naught Q by R plus 1 by 4 pi epsilon naught Q by R. You need to take into account the sign of the charge while evaluating potentials. Potentials calculate ಮಾಡಬೇಕಾದ್ರೆ take into account the sign of the charge. Electric field ಮಾಡಬೇಕಾದ್ರೆ sign ಬೇಕಾಗಿಲ್ಲ. Electric field is a vector quantity. ಅಲ್ಲಿ directions represent ಆಗಿರ್ತದೆ, sign ಬೇಕಾಗಿಲ್ಲ. Clear? Potential due to a positive charge is positive. Potential due to a negative charge is negative. Potential due to a positive charge is positive, and potential due to a negative charge is negative. Am I clear? ಹಾಗಾದ್ರೆ ಒಂದು ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ ಗೊತ್ತಾಯ್ತಲ್ಲ? ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಅಥವಾ ಸ್ಪೆರಿಕಲ್ ಡ್ರಾಪ್, ಸ್ಪೆರಿಕಲ್ ಚಾರ್ಜ್ಡ್ ಡ್ರಾಪ್, it produces a potential equal to 1 by 4 pi epsilon naught q divided by r, right? So with this we'll try to plot variation of potential due to a charged spherical shell with distance. See, we know that electric potential due to a charged spherical shell vary with distance. Have vary ಆಗ್ತದೆ ನೋಡ್ರಿ. Here on y-axis I have plotted potential, and on x-axis I have plotted distance. As long as distance is equal to radius of the shell, ಇಲ್ಲಿ ನೋಡ್ರಿ, this is center of the shell. As long as distance equal to radius, center ಇಂದ surface ವರೆಗೂ potential ಹೇಗಿರ್ತದೆ ಹೇಳ್ತೀರಾ? Center of the shell ಇಂದ surface ವರೆಗೂ potential ಹೇಗಿರ್ತದೆ ಹೇಳ್ತೀರಾ? How will be the electric potential from the center of the shell to the surface of the shell? Center ಇಂದ surface ವರೆಗೂ electric potential ಹೇಗಿರ್ತದೆ ಹೇಳ್ತೀರಾ? Center ಹತ್ರ 10 ವೋಲ್ಟ್, ಈ ಪಾಯಿಂಟ್ ಹತ್ರ 10 ವೋಲ್ಟ್, ಇಲ್ಲೂ 10 ವೋಲ್ಟ್, ಇಲ್ಲೂ 10 ವೋಲ್ಟ್, ಸರ್ಫೇಸ್ ಮೇಲೂ 10 ವೋಲ್ಟ್. ಹಾಗಾದ್ರೆ ಫ್ರಮ್ ಸೆಂಟರ್ ಆಫ್ ದ ಶೆಲ್ ಟು ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಶೆಲ್, ಫ್ರಮ್ ದ ಸೆಂಟರ್ ಆಫ್ ದ ಶೆಲ್ ಟು ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಶೆಲ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಶಿಯಲ್ ರಿಮೈನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಚೇಂಜ್ ಆಗದೇ ಇಲ್ಲ. ಆ ಸರ್ಫೇಸ್ ಇಂದ ಹೊರಗೆ ಹೋದಂಗೆಲ್ಲ ಪೊಟೆನ್ಶಿಯಲ್ ಏನಾಗ್ತದೆ ಹೇಳ್ತೀರಾ? ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಶಿಯಲ್ as one moves away from the surface? Surface in the point ದೂರ ಹೋದಂಗೆಲ್ಲ electric potential ಏನಾಗ್ತದೆ ಹೇಳ್ತೀರಾ? Can you tell me what happens to electric potential as one moves away from the shell? Changes, increases or decreases? ಇಲ್ಲಿ ನೋಡ್ರಿ, as the point goes outside the shell, electric potential varies inversely as the distance of the point. V is inversely proportional to capital R. ಹಾಗಾದ್ರೆ as one moves away from the shell, electric potential has to decrease. Electric potential has to decrease. ಹಾಗಾದ್ರೆ as long as distance is equal to radius, ಇಲ್ಲಿವರೆಗೂ ನೋಡ್ರಿ, distance capital R is equals to R, radius of the sphere. Small r circle ಮಾಡಿ ನೋಡ್ರಿ, this is representing radius of the spherical shell. As long as distance is equal to radius of the spherical shell, electric potential remains constant up to the surface. Center in the, ಇದನ್ನ center ಅಂತ ತಗೊಳ್ರಿ, origin is the center of the sphere. Center of the sphere in the surface of the spherical shell ವರೆಗೂ electric potential constant ಇರ್ತದೆ. From the surface of the spherical shell, ಇಲ್ಲಿಂದ if we move away from the surface of the spherical shell, what should happen to the electric potential? What should happen to the electric potential if we move away from the surface of the spherical shell? What should happen to the electric potential if we move away from the surface of the spherical shell? If we move away from the surface of the spherical shell, potential should decrease. That is represented here. Ilinda decrease ಆಗ್ತಾ ಬಂತು ನೋಡಿ, up to radius small r, from center to radius of the sphere, electric potential remains constant. From the surface, if we start moving away, surface in the dura hodangella, electric potential due to a charged spherical shell goes on decreasing. Adanne illi torsini. When distance is less than radius of the sphere, when distance of the point, R represents distance of the point. When distance of the point is less than radius of the sphere, can you tell me where will be the point? When distance of the sphere, distance of the point is less than radius of the sphere, can you tell me where will be the point? Distance of the point is less than radius of the sphere. Where will be the point? Whether the point will be outside the sphere, on the sphere, or inside the sphere. Inside the sphere. Inside the sphere, the potential should remain constant. That is represented here. Potential constant. At distance equal to R, at distance capital R equal to small r, where will be the point? At a distance capital R equal to small r, where will be the point? At a distance capital R equal to small r, where will be the point? on the surface of the sphere. Very good. At a distance capital R greater than small r, at a point whose distance capital R is greater than small r, the radius ginta distance of point ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದ್ರೆ point should be outside the sphere. So outside the sphere electric potential should go on decreasing. This is the variation of electric potential due to a charged spherical shell with distance. Variation of electric potential due to a charged spherical shell with distance. Up to the surface of the sphere, potential remains constant and then goes on decreasing. Am I clear with this point? Am I clear with this point? Ill nodri. Idadmele, in the last class we have discussed the relationship between electric field and electric potential. I have told you the relationship between electric field and electric potential is E is equals to minus dV by dx. Electric field can be written as minus dV by dx, where dV represents electric potential difference between any 2 points. B ಮತ್ತೆ A ತಗೊಂಡ್ರೆ ಇವೆರಡರ ಮಧ್ಯ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ dV, ಇವೆರಡು ಪಾಯಿಂಟ್ ಮಧ್ಯ ಡಿಸ್ಟೆನ್ಸ್ dx ಇದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ will be given by E is equals to minus dV by dx. You must remember what does negative sign signifies. Equation again. Negative sign shows that electric potential decreases in the direction of electric field. See, due to a positive charge, electric field should be radially outward. This arrow mark is representing direction of electric field. It is representing the direction of electric field. It is representing the direction of electric field. The minus sign here represents that electric potential decreases. Electric potential decreases in the direction of the electric field. See, I have represented 3 points here, A, B, and C. Let us suppose potential at A is VA, potential at B is VB, potential at C is VC. Can you tell me which potential or which point will be at greater potential? Which point will be at greater potential? A, B, C. ಮೂರರಾಗ ಯಾವ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಪೊಟೆನ್ಷಿಯಲ್ ಆಗಿರ್ತದೆ? Which point will be at greater potential? A. A ಇಂದ B ಹೋದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗ್ತದೆ? A ಇಂದ B ಹೋದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. B ಇಂದ C ಹೋದ್ರೆ ಫರ್ದರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಹಾಗಾದ್ರೆ if we move in the direction of the electric field, electric potential goes on decreasing. That is signified by this negative sign. ಅದನ್ನ ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿ ನೋಡ್ರಿ. VA is greater than VB is greater than VC. Potential at A will be greater than potential at B, and potential at B will be greater than potential at C. ಅಂದ್ರೆ ನಾವು A ಇಂದ B ಗೆ, B ಇಂದ C ಹೋದ್ರೆ potentials decrease ಆಗ್ತಾ ಹೋಗ್ತಾವೆ. Potential at A may be 10 volt, potential at B will become 5 volt, potential at C will become 2.5. If we move in the direction of the electric field, electric potential goes on decreasing. That is the significance of this negative sign, right? And ಇಲ್ಲಿ ಒಂದು ಸ್ಪೆಷಲ್ ಕೇಸ್ ನೋಡ್ಕೋಬೇಕು. If E is equals to 0, ಈ equation ನಾಗೆ E is equals to minus dV by dx. In this equation, if E is equals to 0, E 0 ಆಯ್ತು ಅಂತಂದ್ರೆ dV by dx is equals to 0 ಇದ್ದಾಗ dV by dx is equals to 0. If dV by dx is equals to 0, differentiation of what will be 0? Differentiation of what should be equal to 0? Differentiation of a constant always becomes 0. ಹಾಗಾದ್ರೆ differentiation of V is 0 ಅಂತಂದ್ರೆ V must be a constant. V must be a constant. ಎಲ್ಲಿ electric field 0 ಇರ್ತದೋ, ಎಲ್ಲಿ electric field 0 ಇರ್ತದೋ ಆ ರೀಜನ್ ಆಗ electric potential ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ. In the region where electric field is 0, in that region electric potential will be constant. ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂದ್ರೆ ಎಷ್ಟನ ಇರ್ಬೋದು ವ್ಯಾಲ್ಯೂ, 100 ವೋಲ್ಟ್ ಇರ್ಬೋದು, 200 ವೋಲ್ಟ್ ಇರ್ಬೋದು, 300 ವೋಲ್ಟ್ ಇರ್ಬೋದು, 0 ವೋಲ್ಟ್ ಇರ್ಬೋದು. ಯಾವ ರೀಜನ್ ಆಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಇರ್ತದೋ ಆ ರೀಜನ್ ಆಗ ಕಂಪ್ಲೀಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ, ರೈಟ್? We'll illustrate this with an example as well. Am I clear with this point? E is equals to minus dV by dx point clear ada? E is equals to minus dV by dx. Is clear ada? If this is clear, I'll illustrate this V is equals to constant with an example now. Okay, ill nodri. I have told you that electric field inside a charged spherical shell will be zero ಅಂತ ಹೇಳಿನಲ್ಲ. Look here. This is the charged spherical shell. ಈ ಚಾರ್ಜ್ಡ್ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಒಳಗಡೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಇರ್ತದೆ. ಯಾವ ರೀಜನ್ ನಾಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಇರ್ತದೋ ಆ ರೀಜನ್ ನಾಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. ನೋಡ್ರಿ, ದಿಸ್ ಇಸ್ ಅ ಚಾರ್ಜ್ಡ್ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್. ಆನ್ ಇಟ್ಸ್ ಸರ್ಫೇಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ 10 volts. ಹಾಗಾದ್ರೆ ಅಟ್ ಎನಿ ಪಾಯಿಂಟ್ ಇನ್ಸೈಡ್ ದಿಸ್ ಚಾರ್ಜ್ಡ್ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಶುಡ್ ರಿಮೈನ್ 10 volt. ಈ ಪಾಯಿಂಟ್ ಹತ್ರನೂ 10 volt, ಈ ಪಾಯಿಂಟ್ ಹತ್ರನೂ ಪೊಟೆನ್ಷಿಯಲ್ 10 volt, ಈ ಪಾಯಿಂಟ್ ಹತ್ರನೂ ಪೊಟೆನ್ಷಿಯಲ್ 10 volt. ಇಲ್ಲಿ ಹಾಕಿದ್ರೆ ಇಲ್ಲೂ 10 volt ಬರ್ತದೆ. ಹಾಗಾದ್ರೆ ಯಾವ ರೀಜನ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಇರ್ತದೋ ಆ ರೀಜನ್ ಆಗಿ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ. ದಟ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಶೋನ್ ಹಿಯರ್. ಇಫ್ E is equals to 0, V is equals to constant. ಎಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಆಗಿರ್ತದೋ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರ್ತದೆ. Am I clear? ಈ ರೀತಿ MCQs ಬರ್ತವೆ. You will be given a charged spherical shell saying that potential on its surface is 20 volt. The radius of the sphere is 5 cm ಅಂತ ಹೇಳಿ find electric potential at a distance of 1 cm from the center ಅಂತ ಹೇಳ್ತಾರೆ. Will be given a spherical shell of radius 5 cm. Potential on its surface will be said to be 20 volts. Find the electric potential at a point whose distance is 1 cm from its center ಅಂತ ಹೇಳ್ತಾರೆ. Can you tell me what will be the potential at a point whose distance is 1 cm from its center? Whose distance is 1 cm from its center? Potential ಹೇಳ್ತೀರಾ? 20 volts ಇರಬೇಕು. ಯಾಕಂದ್ರೆ in point P, which is at a distance 1 cm, will be inside the spherical shell. At a point inside the spherical shell, electric field is 0. At a point, question is very simple. There is a spherical shell of radius 5 cm. There is a spherical shell of radius 5 cm. Electric potential on its surface is 20 volts. Spherical shell surface male potential 20 volt ade. What will be the potential at a point which is at a distance 1 cm from its center? What will be the electric potential at a point which is at a distance 1 cm from its center? Is my question clear? You have to find out electric potential at a point which is at a distance 1 cm from its center. The point which is at a distance 1 cm from the center will be inside the shell of radius 5 cm or it will be outside the shell of radius 5 cm. Whether it will be inside the shell or outside the shell. The point will be inside the shell. Inside spherical shell, what is the electric field? Inside spherical shell, what is the electric field? Inside a spherical shell, electric field is 0. So potential should be electric field 0 equal potential constant ಇರಬೇಕು. Constant ಅಂದ್ರೆ ಎಷ್ಟಿರಬೇಕು? Constant ಅಂದ್ರೆ ಎಷ್ಟಿರಬೇಕು? Potential at a point inside the spherical shell is potential at a point inside the spherical shell is same as that on its surface. The potential at a point inside spherical shell is same as on its surface. Of surface ಮೇಲೆ ಎಷ್ಟು potential ಇತ್ತು, at a point inside the spherical shell will the potential will remain the same. Is this idea clear? Potential due to a spherical shell. Is this clear? ಈ graphical variation clear ಅದ? ಯಾಕೆ capital R is equals to small r ವರೆಗೂ straight line parallel to x axis ಬಂದಿದೆ ಗೊತ್ತಿರಬೇಕು. Potential in this region is remaining constant. Once distance becomes greater than radius, ಇದು radius small r, ಇದಕ್ಕಿಂತ distance ಜಾಸ್ತಿ ಆದ್ರೆ potential goes on decreasing, right? So this is regarding the relationship between electric field and electric potential and potential due to a spherical shell. ಈಗ ನೋಡ್ರಿ, ಇಲ್ಲಿ we have a problem here. Electric potential of a big liquid drop formed by n small droplets. Electric potential of a big liquid drop formed by n small droplets of liquid, each of radius smaller and each having charge q. We have to now find out electric potential of a big liquid drop. On the liquid drop, the electric potential find out more. How is that big liquid drop formed? That big liquid drop is formed by combining n small droplets of liquid, each of radius small r and each having charge small q. I have shown you some small liquid drops of radius smaller and charge q. I have shown you some n number of small liquid drops, each of radius smaller and charge q. They combine, ivella combine agtave. Combine agi they form a large liquid drop or a big liquid drop of radius capital R. ಇವೆಲ್ಲ ಕಂಬೈನ್ ಆಗ್ತಾವ, ಸ್ಮಾಲ್ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ಸ್ ಕಂಬೈನ್ ಆಗಿ ಒಂದು ಬಿಗ್ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತದೆ ಅಂಡ್ ಇಟ್ಸ್ ರೇಡಿಯಸ್ ಇಸ್ ಕ್ಯಾಪಿಟಲ್ ಆರ್. ಈ ಬಿಗ್ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ ರೇಡಿಯಸ್ ಕ್ಯಾಪಿಟಲ್ ಆರ್ ಅದೇ. ಹಾಗಾದ್ರೆ ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆನ್ ದಿಸ್ ಸ್ಪಿಯರ್ ಆರ್ ಬಿಗ್ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್? ಇದ್ರ ಮೇಲೆ ಟೋಟಲ್ ಚಾರ್ಜ್ ಎಷ್ಟಿರ್ಬೇಕು ಹೇಳ್ತೀರಾ? ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆನ್ ದಿಸ್ ಬಿಗ್ ಡ್ರಾಪ್? ಟೋಟಲ್ ಚಾರ್ಜ್ ಆನ್ ದಿಸ್ ಬಿಗ್ ಡ್ರಾಪ್ ಎಷ್ಟಿರ್ಬೇಕು? See, charge on each drop is q. ಒಂದೊಂದು ಡ್ರಾಪ್ ಮೇಲೆ ಚಾರ್ಜ್ ಸ್ಮಾಲ್ q ಅದೇ. ಅಂತಾವ್ n ಡ್ರಾಪ್ಸ್ ಅವೆ. I have told you charge is additive in nature. You can just add charges algebraically. ಒಂದು ಸ್ಪಿಯರ್ ಮೇಲೆ ಚಾರ್ಜ್ q ಇದ್ರೆ ಎರಡು ಸ್ಪಿಯರ್ ಮೇಲೆ 2q ಇರ್ತದೆ, ಮೂರು ಸ್ಪಿಯರ್ ಮೇಲೆ 3q ಇರ್ತದೆ, ನಾಲ್ಕು ಸ್ಪಿಯರ್ ಮೇಲೆ q ಪ್ಲಸ್ q ಪ್ಲಸ್ q ಪ್ಲಸ್ q 4q, 5 sphere ಮೇಲೆ q plus q plus q plus q plus q 5q. On n spheres, the total charge will be n into q. On the n spheres, total charge will be n into q. So this big liquid drop is obtained by combining all these small charged spheres. However, the total charge on this sphere must be n into q. The total charge on the sphere must be n into q. Very good. Is it clear? This point is clear. No problem with the total charge. No problem with total charge. How total charge on the large sphere became n into q? Is it clear? Okay. If this is clear, we will now think of what will be the potential of each small sphere. What will be the potential of each small sphere? One small sphere though potential on its surface. We are not finding out potential at any point inside or outside the spherical shell. We are finding out potential on its surface. What will be the potential due to a small sphere antandre? Potential due to a small sphere will be 1 by 4 pi epsilon naught q by r. Potential due to a small sphere is 1 by 4 pi epsilon naught q by r. Nodri small sphere the radius r ittu, charge q ittu. So its potential must be 1 by 4 pi epsilon naught q by r. This is potential due to a small sphere. Next, we will calculate what is potential due to a large sphere. See, here is a large sphere. Charge on large sphere is capital Q and its radius is capital R. Right? Potential of large sphere is 1 by 4 pi epsilon naught Q by R. Capital Q by capital R. Capital Q is the charge on large sphere. R is the radius of large sphere. We have already calculated what is the value of capital Q. What is the value of capital Q? Capital Q ಗೊತ್ತು ನಮಗೆ. Can we calculate what will be the radius of this large sphere? Can we calculate what will be the radius of this large sphere? ಈಗ potential ಗೊತ್ತಾಗಬೇಕು ಅಂತಂದ್ರೆ charge ಎಷ್ಟದೆ ಗೊತ್ತಿರಬೇಕು. Capital Q ಅದು ನಮಗೆ ಗೊತ್ತು. Capital Q is equals to n into small q ಅದು ಗೊತ್ತು. Do we know the radius of this large sphere? n power 1 by 3 ನೆನ್ನೆ ಮಾಡಿ. ಹ್ಯಾಗ್ ಮಾಡಿ ನೋಡ್ರಿ. Radius of spheres ಯಾವಾಗ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು? ಕಾಂಬಿನೇಷನ್ ಬಂದಾಗ n drops combined to form one large sphere ಅಂದಾಗ always use this rule for finding out the radius of large drop. We know that volume of large sphere is equals to n times volume of small sphere. Large sphere is formed. See, large sphere is formed by combination of n small spheres. Hagadre volume of a large sphere should be equal to n times volume of small sphere. Small sphere volume ಎಷ್ಟದು ಅದಕ್ಕೆ into n ಮಾಡಬೇಕು. So volume of large sphere is equals to n times volume of small sphere. You know that volume of a sphere, large or small ಅದು ಬೇರೆ. ಆಮೇಲೆ volume of a sphere is 4 by 3 pi r cube. Volume is 4 by 3 pi r cube. Area is 4 pi r square. Confuse ಮಾಡ್ಕೋಬಾರದು. Area is 4 pi r square. Volume is 4 by 3 pi r cube. Volume of large sphere is 4 by 3 pi. Large sphere radius ನೋಡ್ರಿ capital R. So volume of large sphere is 4 by 3 pi capital R cube. That is equals to n into volume of small sphere. Small sphere radius nodri eštade small r. So n into volume of small sphere is 4 by 3 pi small r cube. 4 by 3 pi, 4 by 3 pi cancel adre will be left out with r cube is equals to n small r cube. R cube is equals to n small r cube. So radius of large sphere capital R is equals to n power 1 by 3 times small r. Radius of large sphere is n power 1 by 3 times radius of small sphere. Radius of large sphere is n power 1 by 3 times n power 1 by 3 under cube root. Radius of large sphere is n power 1 by 3 times small sphere. Remember this equation. ಈಗ ಹಾಗಾದ್ರೆ what will be the potential of large sphere? Large sphere potential ಕಂಡುಹಿಡಿಯಬೇಕಲ್ಲ ಈಗ. V is equals to 1 by 4 pi epsilon capital Q by capital R. Potential due to large sphere is V is equals to 1 by 4 pi epsilon. Capital Q is Nq divided by capital R is n power 1 by 3 R. N power 1 divided by n power 1 by 3. N power 1 divided by n power 1 by 3 ಮಾಡಿದ್ರೆ n power 2 by 3 ಬರ್ತದೆ. A power m divided by A power n is A power m minus n. N power 2 by 3. So ಈ n by n power 1 by 3 n power 2 by 3 ಅಂತ ಬರ್ತೀನಿ. 1 by 4 pi epsilon Q by R as it is ಹಾಗೆ ಬರ್ತೀನಿ. N by n power 1 by 3 is n power 2 by 3. Left out is 1 by 4 pi epsilon Q by R. Can you tell me what is 1 by 4 pi epsilon small q by small r? What is 1 by 4 pi epsilon small q by small r? Whether it's the potential of large sphere or it's the potential of small sphere. 1 by 4 pi epsilon small q by r. Small q by r. 1 by 4 pi epsilon small q by r. It's the potential of small sphere. ಅದಕ್ಕೆ ನೋಡ್ರಿ potential of big sphere is equals to n power 2 by 3 times n power 2 by 3 ಹಾಗೆ ಬರ್ತೀನಿ times 1 by 4 pi epsilon q by r is written as v small. Potential of big sphere is equals to n power 2 by 3 times potential of small sphere. Potential of big sphere. This is a formula that is to be remembered. Potential of big sphere is equals to n power 2 by 3 times potential of small sphere. Here I have given you an example. ಇಲ್ಲೊಂದು ಎಕ್ಸಾಂಪಲ್ ನಾನು ಸಾಲ್ವ್ ಮಾಡೀನಿ, ಎರಡು ರೀತಿ ಸಾಲ್ವ್ ಮಾಡೀನಿ. ನಿಮಗೆ ಯಾವ್ದು ಕನ್ವೀನಿಯಂಟ್ ಅನಿಸ್ತದೋ ಆ ಮೆಥಡ್ ಫಾಲೋ ಮಾಡಿ ಈ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಒಂದು ಸರ್ತಿ ಸಾಲ್ವ್ ಮಾಡ್ರಿ. 8 liquid drops, each of radius small r and charge small q combined to form a single large drop. ಇಲ್ಲಿ number of drops that combine are given 8. 8 liquid drops, each of radius small r and the charge small q combined to form a single large drop. If potential of each small drop is Vs, notice potential of each small drop is given as Vs. Vs under potential of small drop anta. Find radius of large drop. Can you tell me what will be the radius of large drop? Small drop the radius nodri smaller ada small drop radius. Can you tell me what is the radius of large drop? Radius of large drop ಎಷ್ಟಿರ್ತದೆ ಹೇಳ್ತೀರಾ? We know the formula for radius of large drop. Radius of large drop is n power 1 by 3 times radius of small sphere. Can you tell me what will be the radius of large drop, which is obtained by combining 8 small drops? Very good. 2r. We know that radius of large sphere is given by r is equals to n power 1 by 3 into r smaller. Here n is given as 8. Number of drops given is 8. So n power 1 by 3 ಅಂತಂದ್ರೆ 8 power 1 by 3. 8 power 1 by 3 is nothing but cube root of 8. Cube root of 8 is 2. So radius of large sphere is equals to n power 1 by 3 ಎಷ್ಟು ಬಂತು ನೋಡ್ರಿ 2. So n power 1 by 3 ರಲ್ಲಿ 2r. So radius of large sphere is 2 times the radius of small sphere. This is the radius of large sphere. Once you get the radius of large sphere, you can calculate potential of large sphere. Can you tell me what is the potential of big sphere? What is the potential of big sphere? Potential of big sphere is n power 2 by 3 times potential of small sphere. ಈ n power 2 by 3 ಎಷ್ಟು ಹೇಳ್ಬಿಡ್ರಿ ಸಾಕು. n power 2 by 3 ಎಷ್ಟು ಹೇಳ್ಬಿಡ್ರಿ? 8 power 2 by 3. 8 power 2 by 3. ಅದನ್ನೇ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಕರೆಕ್ಟ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಮಾಡಿ ನೋಡಿ. 8 power 2 by 3 is nothing but cube root of 8 square. 8 power 2 by 3 is nothing but cube root of 8 square. Cube root of 8 square is 64. Cube root of 8 square is cube root of 64. Cube root of 64 is 4. ಈ evaluation ಗೊತ್ತಾಗಬೇಕು. How to evaluate 8 power 2 by 3? 8 power 2 by 3 is nothing but cube root of 8 square. Cube root of 8 square is nothing but 64. Cube root of 64 is 4. ಹಾಗಾದ್ರೆ what will be the potential of big sphere? Potential of big sphere is 8 power 2 by 3 is 4. Potential of big sphere is 4 times potential of small sphere. Potential of big sphere is 4 times potential of small sphere. ಅದನ್ನ evaluate ಮಾಡಿ. Potential of big sphere is n power 2 by 3 times potential of small sphere. n 8 ಅಂತ ಕೊಟ್ರೆ 8 power 2 by 3 is 4. So potential of big sphere is 4 times potential of small sphere. However, can you tell me what happens to the potential of big sphere when obtained by combining the small spheres? Potential ಏನಾಗ್ತದೆ ಹೇಳ್ತೀರಾ? Potential ಏನಾಗ್ತದೆ? Increase ಆಯ್ತಾ decrease ಆಯ್ತಾ? On combining n small drops to form a big drop, what happened to the potential? Increased or decreased? Potential increased or decreased? Increased. n power 2 by 3 times increase ಆಗ್ತದೆ. Potential of big drop is n power 2 by 3 times potential of small drop. Am I clear with this? Idistu clear? Idistu clear idre tomorrow we'll discuss about electric potential at a point due to a dipole. Dipole ಇಂದ ಎಷ್ಟು electric potential create ಆಗ್ತದೆ ನೋಡೋಣ ನಾಳೆ. Am I clear with this? Yes. ಇದ್ರಾಗೆ ಒಂದು ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಮೂವ್ ಆಗ್ತದೆ.